All right, our last topic we're going to talk about for polar coordinates is converting polar and rectangular equations into the other form. So polar to rectangular, rectangular to polar, but this time with equations. So not just the points, but the entire equation. As a reminder, these are the formulas we went through when we learned how to change our coordinates. So we took the formula x squared plus y squared equals r squared, and we turned that to r equals plus or minus the square root of x squared plus y squared. We took our cosine, sine, and tangent formulas with opposite over adjacent, etc., and rearranged those to get the x and the y and the theta by itself. And that gave us these three formulas down here with r cosine theta, r sine theta, and the inverse tangent function. So we're going to use all of these equations in all of their different forms to help us convert from one polar equation or one rectangular equation to the other. So here are the steps we're going to use to do that. First, you're going to need to manipulate your original equation if necessary. And for that, you kind of have to think a little bit ahead and kind of compare that to these formulas that we have and see, okay, how could I get it to fit into that form that maybe I have in one of those formulas? Things you might need to do, you might need to expand a square, you might need to multiply by r, you can add, subtract, multiply, and divide, obviously, but those are the kinds of things you're going to need to do for your equations before you can go through and then substitute. Next step would be substituting, trying to convert any of your r's to x's or your r's to y's or your thetas to a value if depending on which way you're trying to go. So the whole idea for substituting is to try to get the correct values for polar or rectangular depending on which one you want to get into. And then finally, you're going to manipulate the equation a little more if you need to. Obviously, if it's a polar equation, you need to get the r by itself. That would be what step 3 is. Once you've done all your substitution, get your r by itself. If it's rectangular, you'll need to either get y by itself to get a line, or if you have a circle equation, you'll need an x squared plus y squared formula to do that to get a circle. And you'll see that in some of the examples. All right, so let's take a look at our first example. So it says convert the equation r equals 4 cosine theta to rectangular. So we're going from polar to rectangular. And before I tried to start, I thought about, okay, what kinds of things do I need? Well, I might need this r squared formula because I have an r value in here. So that'll give me r squared equals x squared plus y squared. And also the x formula, x equals r cosine theta. Now, I can't do anything at the moment because I only have one r value and the equation I want to use has an r squared value. So to do that, I need to go through and I need to square, or I need to multiply by r so that I get an r squared value. So that's what I did first. I took the original equation multiplied by r. Distribute that and you get r squared equals 4r cosine theta. Then you're going to go through and fill in or replace the things on the left side everywhere there's an r or an r cosine theta. So you'll see I put in x squared y squared on the left side, and this whole r cosine theta I substituted with x. So that's steps 1 and 2. Manipulate, then substitute. Now we're going to manipulate again because this x squared plus y squared equals 4x is not really a great formula for us to have, but especially because you have an x squared and a y squared, then you know you're probably going to have a circle equation. So I'm going to go through and I'm going to get everything on the same side and group my x's together. And then I'm going to notice that I have an x squared and a 4x, but I do not have a linear term there. So I'm going to need to complete the square to do that. So I'm going to take that middle term, divide by 2, square that. That gives me a plus 4 over here so that I get a complete square inside the parentheses. If I add 4 on this side, I need to add 4 on this side. And then this factors very nicely. That's the whole point of completing the square into x minus 2 squared. And then over here we have 4. That gives me the equation of a circle centered at 2, 0 with a radius of 2. So you might need to go back and review your circle equations too if you haven't done that in a while, of how we got that equation and why it looks like that and how it gives us that information about circles and radius of 2. Okay. All right, step 2, or question 2, says convert theta equals 120 to rectangular. Clearly neither of those is in rectangular form, but the formula we're going to want to use here is the tangent of theta equals y over x. So if I'm starting with theta, then I need to do the tangent of both sides so that I get the tangent of theta. That's great. Then I can replace that with y over x. The tangent of 120 is a number, so I substitute that one number from that unit circle. And then I'm going to get this in y equals form, so I'm going to multiply by x on both sides, and I get negative square root 3x. And that's a line where the slope is negative square root of 3. All right, r equals 4 secant theta. First thing I'm going to do there is go ahead and change that to 4 over cosine theta. And then I'm going to multiply by cosine theta on both sides. That gives me that r cosine theta that I'm looking for to change that to an x. Plug in that x and I get x equals 4, which is a vertical line. So those are all your polars to rectangular examples. Next up is rectangular to polar. So here we go. We're going to start with x equals 5. I'm going to use the equation x equals r cosine theta. Plug in r cosine theta for x. So now I have r cosine theta equals 5. Divide by the cosine of theta so that I get r by itself, because in polar equations, remember, r is by itself. And that gives me r equals 5 over cosine theta. Remember, 1 over cosine of theta is really secant, so this becomes r 5 secant theta. All right, over here, 3x plus 4y equals 2. I'm going to need both of those. X equals r cosine theta and y equals r sine theta. Plug those in for x and y. And then I'm going to go ahead and factor out that r. So notice both of those groups have an r in them. So that's my greatest common factor. Pull that out in front. I'm left with 3 cosine theta and 4 sine theta. Divide that out so that r is by itself. And that's how I get 2 over 3 cosine theta, 4 sine theta. And that's where you want to leave that one. All right, last one. I have a nice little circle here centered at 0, 1 with a radius of 1. I'm going to use y equals r sine theta and r squared equals x squared plus y squared. So over here in my original problem, the first thing I'm going to do is get rid of this binomial squared and turn it into a trinomial. So you're going to do y minus 1 times y minus 1 and FOIL if you have to, or use that shortcut. Y squared minus 2y plus 1 is the trinomial that's equal to y minus 1 squared. I'm going to group my x squared and y squared together, and that gives me r squared. And then here, where I have another y, I'm going to plug in r sine theta. Then I'm going to get rid of one r on each side by dividing by r, or dividing all groups by r. So r squared divided by r gets just r. 2r sine theta just gives me 2 sine theta, and then 0 divided by anything is still 0. So now I have r minus 2 sine theta equals 0. Add 2 sine theta to both sides, and that gives me the equation r equals 2 sine theta. There's a whole bunch of practice problems with answers at the bottom if you want to practice some more of those skills before you work on your My Math Lab. The My Math Lab's assigned on Wednesday and due the following Wednesday on May 6th. If you have any questions, remember we have office hours on Thursday on Zoom from 10 to 12.